Hello and welcome. We'll just give it a moment and then we'll get started. All right, I think we can jump into it and I'm sure people will join as we continue. So welcome everyone. Thank you for joining us on this Thursday and very happy holidays to our Indian friends here joining us during the holiday season. Thank you for making the time on this special day. My name is Justin. I'm the head of procurement solutions at Odyssey. And we're delighted to host this webinar today in partnership with AmpereHour and Ayush Misra, who is the CEO of AmpereHour, a leading battery BESS integrator based in India. And today we'll tell you all about how AmpereHour's energies, how AmpereHour's energies, how AmpereHour's energy intelligent storage, and about how Odyssey's supply chain credit can support in accelerating microgrid deployment. So thank you so much for joining us today. I'll just jump into it, and just a few admin notes though before we begin. Some of you have submitted questions already when registering for the webinar, and we're grateful for that. And we will address a lot of those questions either throughout the presentation, but also if it's not addressed in our presentations, we'll definitely address it at the end in Q&A. Please don't hesitate at any time to share your questions in the Q&A box here on the Zoom link, or simply in the chat box, whether it's technical, commercial, whatever comes to mind. And then Ayush and I will try our best to address those questions at the end of the webinar. Some of you will ask, is this presentation going to be available? And the answer is certainly, definitely yes. It will be available following this presentation, both the recording, which we will make available on YouTube, but also the slides. So hopefully, if anything piques your interest, we can definitely get into it further in follow-up to this presentation. All right, now jumping into it. So I just want to share information about Odyssey and our supply chain credit and services specifically as relevant to this partnership with AmpereHour. So with Odyssey Supply Chain Credit, you can say goodbye to cash flow nightmares, own your own supply chain, and foster more business growth. Who is Odyssey? We are the largest climate tech platform enabling financing of distributed renewable energy projects globally. We are a team of industry professionals, from top-tier banks to fund managers, DFIs, development finance institutions, green banks, IPPs, EPCs, and OEMs. We work across the value chain. We specifically have two offerings. One is a digital platform to streamline solar financing workflows, which also offer asset monitoring at an inverter level in most cases for solar projects, which allows quickly identifying quality projects from pre-approved installers and reduces processing time. So we have a number of partnerships, commercial banks, other funders, project funders, and EPCs that leverage our digital platform. And then we also offer our supply chain credit to pre-finance solar loans and offer complete financing package in support of the DRE sector. So we'll dive into those offerings today. So as I mentioned, we work across the entire ecosystem of DRE. So that means we work with financiers, we work with OEMs, we have a number of what we say in the US anyway, original equipment manufacturers, let's just call them suppliers that we work with, most of whom are tier one solar energy equipment companies, including many Indian companies such as AmpereHour. And we also work with a number of solar companies across the globe. We are all over the world. We are a distributed company supporting the distributed sector. We are based across Africa, in which we support AmpereHour's expansion and projects across the continent. We are also based across Asia, of course. Last year opening across India, and excited to say we have millions of dollars under deployment currently in India, and it's rapidly expanding. We're in Mexico and Brazil as well, and actively looking at other countries. A little bit of Odyssey by the numbers. We have over 3,000 solar companies on our platform. We've deployed more than $2.8 billion of capital on our platform. We have financed more than 2.3 million systems across the globe, and we have over 50 financing facilities that we're actively supporting or have supported in the past. We work with, as mentioned, private and public led financing groups such as the World Banks, the AFDB, UNDP, and a number of private sector led financiers as well. Diving into our solution a little bit, we are proud to say that we marry both credit from financing, from the financing arm of our business, as well as supply chain services. So on the credit side, we can offer more working capital, off-balance sheet lending, on-demand credit, flexible repayment schedules specifically designed for the DRE sector to meet milestone payments. And this all allows for no additive borrowing on a balance sheet of a solar company. On the supply chain side, we have robust procurement solutions and a team with deep networks of clearing and forwarding agents and last mile delivery partners, warehousing, etc. And we can achieve economies of scale in support of supply chain. We can procure under best prices and terms, as we have a partnership with AmpereHour that allows essentially the DRE sector to unlock what would otherwise be only available for larger projects and large orders. We can unlock that for multiple distributed energy projects. And overall, this allows for access to our global network for renewable energy companies. So diving into the supply chain credit side of the business, if you think of a project cycle as procurement from source, shipped, let's say from India in this case, arriving at the port, clearing to customs, and then COD and commissioning, we offer credit for every step of this value chain. So we have what's called our procurement credit solution, which can support up to the warehouse or the site of a project. And then we have our construction credit solution, which can support all the way through commissioning. So in this scenario, we would pay the supplier, say AmpereHour, and then we would add our credit offering onto that solution, in which then Odyssey essentially resells the equipment to the renewable energy company or IPP or financier, etc., under our terms with extended credit. We do ask for a deposit. We can extend the credit for 6 to 12 months, depending on what's available. Our aim is to be much faster than a bank in doing this and have a much simpler, hassle-free process in the application for this credit. So if you have a project in mind, whether it's in India or across Africa or elsewhere, we would love to hear about it and see how our solution could be right for you. We currently have a minimum threshold of around $100,000. And then we can, and we go up to about 5 million, and we can look at only the CapEx of your project from suppliers. So if you want to procure AmpereHour and let's say panels and you have companies in mind, we would love to hear from you, and then we can support you in that procurement, both with our supply chain, if supply chain services are required, but also, of course, the credit offering. So this is designed to address sector-specific needs. So flexible credit allows for easier cash flow management. As I mentioned, it's off-balance sheet financing. No personal guarantees are required. We can customize repayment schedules based on your own project requirements. So as you pay back the facility, the cost of that facility would lessen. we have hassle-free application, as I mentioned, and very competitive rates and terms. So this credit offering is complemented with our centralized procurement offering with Odyssey. So how does this work? Well, we have a number of OEM partnerships that we work with, both kind of panels, battery, inverter companies, but also balance of system companies. Some of the names we work with, of course, are outlined here. Obviously, AmpereHour is one of them. And we have varying levels of partnership with these OEMs. Some OEMs, we have a best price guarantee framework in which we have pricing guaranteed to Odyssey. Therefore, on any procurement, we can extend those terms to our partner network. And others, we have channel partnerships. Others, we have kind of local aftercare support and technical representation. So it looks very different across the board. We do not pretend to have a monopoly on all the suppliers out there. And so if you have a supplier in mind, the way we're able to kind of achieve these economies of scale and unlock these aggregate pricing is by hearing from companies that say, hey, I have this supplier and I need to have this project financed, and then we support them in that transaction. We procure to whatever price they've been able to negotiate, or if we can support further, we will try to do so. And then we start to unlock these partnerships through orders, because the reality is one order plus another order is always larger, right? So that's how we are able to build these partnerships with suppliers. And then, of course, we add the supply chain support at every step of the way. We have internal specialized staff that are procurement specialists. We can offer benchmark pricing to help you make robust procurement choices. We understand panel prices, for instance, right now are fluctuating rapidly, and we can share with you, hey, here's a few choices. Here's some options of what we're seeing in terms of price per wattage. And then we can help you track their procurements at every step of the procurement cycle. So our aim is to remove hurdles from the procurement process, de-risk your supply chain, and overall improve your economies of scale. As I mentioned, doing benchmarking, leveraging our network of warehousing partners and last mile delivery service partners, unlocking kind of our global presence to make it easier for you to enter new markets. Let's say if you have new customers in varying countries. And then we also have robust economic and social governance packages that we perform on our OEM partners, such as AmpereHour. So if you're a solar company, or if you're an IPP or financier or developer, and you really require a repository of suppliers to work with that you know have been vetted and diligenced, we have that at Odyssey. And then, of course, we have the related supplier vendors management. So if you're interested, we'd love to kind of get into the details and understand your requirements, how your working capital usually works. Our solutions are not just for smaller, medium-sized DRE players, but it's really for everyone across the value chain, because we find even if the largest players find value in our financing solutions and some of our supply chain offerings, where they can mix some of their finance offerings. All right. We will do Q&A at the end. And so I will turn it over now to our friend Ayush Misra, who is the CEO of AmpereHour, who will walk us through some of AmpereHour solutions and how these solutions are perfect for your next project and how they can be financed with Odyssey. So Ayush, over to you, my friend. Thank you.
Thanks a lot, Justin. I hope I am audible. So firstly, it's great to be here and to be presenting before you. We've put together a small deck that I make, and maybe we'll run you through to give you a little bit of an introduction of like what we do. Let me share my screen. Is this visible?
Yep, we can see it.
Yeah. So to give you a little bit of an introduction to Ampere Hour, like essentially we are an energy storage solution provider. We will plug and play energy storage hardware. These can be packed into 20 feet containers, and they're fairly modular, so you can set up energy storage plants that can go from a couple of hundreds of kilowatt hour all the way up to hundreds of megawatt hour through the same architecture. There's two key parts to the whole platform. One, which we call AH Stack, which is the hardware side of the entire offering. This would come inbuilt with batteries, power electronics, control systems, fire protection systems, and so on. Basically, an infrastructure that allows you to store an electron at the lowest levelized cost for your application. The second part of the platform is what we call ELINA. And ELINA is a proprietary software that we've developed in-house that allows you to intelligently manage, one, the safety of the entire system during operations, and also to optimize the charging and discharging of the batteries in a manner that creates the maximum value for our customers. So AH Stack combined with ELINA provides you with one of the most advanced energy storage infrastructures that might be available for sorry, excuse me, I think I just pressed the last one. Let me go back. It creates one of the most advanced infrastructure for building smart microgrids. Now, just digging deeper into what's really inside this entire container. So it would comprise of four key parts. The first would be your batteries. So these would be typically lithium ferrous phosphate, which seems to have become the industry norm. These are, again, sourced from some of the best cell manufacturers in the globe. In addition to that, you have electronic components like inverters that would convert DC to AC to run to create your microgrid. The third would be a balance of systems. So balance of system would typically comprise of various other subsystems like fire protection or thermal management systems. These batteries have to be operated within a certain temperature range, or metering systems, safety systems, and so on. So that all gets clubbed into a balance of system. And then the fourth part is the software, which we call ELINA, which is the brains of this entire thing that commands and controls every single subsystem that is within this entire infrastructure. Just to walk you through a little bit of our own journey so far. So we, as a company, started out in 2017. At that particular point in time, battery prices were still extremely high, and the only application that made commercial sense was to put them in places where either the grid was absent or where the grid was very unreliable. So we did a lot of work in electrifying rural villages in India, in the states of Uttar Pradesh and Bihar. We worked together with the Rockefeller Foundation to do a lot of consulting work initially to understand the challenges associated with setting up off-grid rural remote microgrids. We co-authored a technical monitoring guide for microgrids along with them as well. And maybe my colleague can also share a link of this technical guide if any of the project developers might be interested in learning about some of those findings of operational microgrid projects in India. And coming out of that entire study, we realized that there was a need for creating a good plug-and-play solution for these remote pockets that use state-of-the-art equipment and also have a digital layer that can fundamentally create intelligence in terms of both commissioning the system as well as operating it throughout the tenure of your contract. Since then, the scale has gone up quite a bit as battery prices have also fallen. And now, today, happy to inform that we're essentially doing pretty large-scale grid-scale projects as well. Some of these are 50 to 360 megawatt hour. We have a cumulative pipeline that exceeds 1 gigawatt hour right now, which really gives us a little bit of an economics of scale in terms of being competitive in terms of our own supply chain and being able to bring down costs for all our customers. Now, a specific case study that I wanted to talk about in this webinar was a recent project that we commissioned in Gabon. This project was a 2 megawatt, 8 megawatt hour usable capacity microgrid clubbed to a solar plant, roughly around 2.5 megawatt peak. The system is being utilized to power a special economic zone, which will house industries and various types of businesses. The entire operations of this microgrid is now being run fully remotely and in an automated manner through a combination of good engineering pre-built skids and smart control systems. So to explain to you like two parts of this entire system. So I think the battery portion is something that is fairly well understood by a lot of players. You get a 20 feet container that would house your batteries. What the innovative part of this entire project was that we created a skid mounted system that would comprise of your inverters, your transformers, your switch gears, your EMS, the energy management system, all into a plug and play pre-wired, pre-mounted skid that was shipped out from India. And uh, the developer only had to do some basic civil engineering, provide us with internet connection, and we actually switched on the plant. So that removed a lot of the last mile integration work and the accessibility to high quality engineering resources at the site to be able to commission a microgrid in these remote pockets. Now, just to give you a sense of what we were able to achieve, we were able to cut down the installation time by about 50%. We were able to save a lot of costs for the developer as well. And because everything was pre-wired and pre-fitted at the factory itself, the quality of build of this microgrid is substantially higher than if you were to integrate it at the site. Now, at Ampere Hour, we have been working on various different projects in Africa, whether that's in Gabon, in Nigeria, in Mozambique, in Djibouti, with various players and for different types of applications. These could range from off-grid rural electrification projects to industries wanting to set up behind-the-meter solar microgrids. We have demonstrated that our systems can be applied for all of these use cases. And through the Elena software, essentially, we are able to provide that last mile solutionizing that very often product players find hard to achieve. Now, Odyssey and Ampere are essentially tied up on this particular webinar and to really fundamentally explore how do we together solve financing problems for end installers, developers, and so on. And um, in one of the projects that I mentioned earlier, we have been able to provide an offering wherein we are able to make the entire project financeable from a working capital standpoint for the end installer, thereby making the whole project feasible. We are very keen to work together with other installers or developers as well to replicate that particular model in terms of providing a plug-and-play energy storage solution clubbed with a financing solution that can be provided by Odyssey that could really help create very high quality, well built out microgrids for end developers. Just in terms of our own experience, we have installations in over 10 countries. We have 200 plus sites where our software has already been installed. We have 55 plus sites where we have set up full-fledged energy storage systems. From a client perspective, some of the names are large names in the microgrid space, whether that's Husk, PowerGen, Rise. We have global names like Coca-Cola, Siemens, SoftBank Energy, Schlumberger, and so on as our clients. I will halt here and would love to hear any questions that you might have. Please feel free to reach out to us as well in case you'd like us to work together on a project. Thank you very much. I'll hand it over to Justin just in case he wants to lead the Q&A.
Thanks so much, Ayush. Yeah, definitely. Thanks so much for the overview. Impressive history of the company and exciting to see what's next and what you're currently working on. So I think we'll now move to Q&A. We welcome any questions you may have. You can just pop them into the chat box as I mentioned. I think we'll start with some questions that came in over registration. We can kind of start with perhaps the cost and economies associated with storage. I think we all recognize the elephant of the room in the room of any renewable energy system is the battery system, right? It's exciting that there's been initial adoption, particularly with grid tied and more stable grid markets of the world. In some ways, I think emerging markets, particularly African economies, have been ahead of the curve with storage over the last few years. But now it's exciting to see kind of even more developed places of the world catching up and understanding the benefits of leveraging this asset at any given time. Obviously, critical to make that happen is the financing, and hopefully Odyssey can help address that in terms of the short-term angle of any project, right? Where the upfront cost is expensive, we can come in, bridge that gap all the way until commissioning, but we also recognize that's sometimes not enough. That's why IPPs and the entire ecosystem is important. So I guess Ayush, besides just saying Odyssey, right, which I think can help solve some of these problems, but what are some other ways and other things you've seen to kind of help address that upfront capex associated with storage, and what are you seeing kind of as some of the solutions out there?
Right. So I think we need to keep a slightly more holistic view of costings when building out microgrids. I think it is quite clear that solar plus storage, the landed cost of an electron works out to be cheaper than a diesel generator, for example, in many applications. So clearly, like from a cost economics perspective, we are already in the era where we're not debating whether solar and storage is cheaper than diesel or not. I think that debate is settled. Now, the second part is, given that we're building a solar plus storage plant, how do we optimize the overall cost of the solar plus storage farm or plant to be able to essentially build out my system at the lowest levelized cost? Now, at Ampere Hour, what the approach that we take is a slightly more solutions approach rather than a product approach. We actually look at what the end use case is. We look at what is the project really fundamentally trying to achieve. Is there something that is a technical optimization that can be done in the last mile? And we really try to optimize for that particular use case. Now, we have worked on various different projects so far, so we have a little bit of a template in terms of what works where and so on. But in terms of the costs, the approach that we take is to really optimize cost at a system level rather than optimizing it just purely from reducing cost of batteries or power electronics. When you reduce cost of batteries or power electronics, it's not like the OEM is essentially at his back end, like sort of doing the project in a loss. It's very often that they're either compromising on some level of safety or on the grade of material that is being utilized and so on. So we need to sort of keep a slightly more holistic approach and talk about levelized costs rather than talking purely about capex, because these are long-term energy assets. They would last you 10, 15, 25 years. And what you want to make sure is that the asset and the capex that you're putting in lasts you that for that long, that the warranty conditions and the contracts that you have are also created in a manner wherein the OEM or the solution provider from whom you've bought everything is there in partnership with you throughout the journey of that particular project, and not just somebody who's selling you an equipment and then is done. So that would be my thought on sort of how to evaluate costs.
Makes sense. I think maybe we can continue on the kind of commercial stream of questions and address some points related to, your solutions and our solutions before we dive more into technical. So I see at least one technical question came in, which we can come to. So we encourage you to keep sharing any questions that come to mind though. So yeah, we're looking at the levelized cost makes complete sense for storage and thinking about related ecosystem of O&M associated with that makes complete sense as well. I mean, mentioning that project that requires kind of no on-site support is incredible, and to see that that's all an in-house technology as well, that's allowing that is even more incredible. Well, we have another question here about the difference in costing between kind of smaller scale projects and larger scale projects, and what can kind of be, obviously standardized, scalable, and where's the kind of a depreciating point of cost related to kind of scale. What's been your experience there, and what insight could you share?
That is a very, very good question. And to be honest, like it comes up in our board meetings very often, like in terms of how much to solutionize, how much to standardize, and so on, even from a scale point of view. So I think if I work from top down, I think we are seeing a standardization of a 20 feet container in the slightly larger scale segment. If you look at all the utility projects that are more than, let's say, 5 megawatt hour, you are seeing a standardization of the 20 feet container solutions becoming the norm in those types of projects. So I would say anything beyond 5 megawatt hour, it's sort of like easier to have like a standard configuration of a 20 feet container and an AC skid with, like, let's say a 2 megawatt PCS and transformers built on top of it, plug and play, you ship it to site, basic wiring is done, internet connection is provided, we switch it on. I think that scale, I think, is becoming easier to manage. At the lower end of the spectrum, as I start going below 1 megawatt or 1 megawatt hour, you have cabinet-based solutions which have been standardized. So, for example, you can find standardized solutions that are 383 kilowatt hour or 373 kilowatt hour, 279 kilowatt hour. These are standardized blocks or ratings that have been created based on the typical cell that is getting standardized. So if your battery cell is getting standardized, your pack ratings and your rack ratings are also getting standardized. And at a cabinet level, like essentially you are seeing minimum sizes of about 233 is where I've seen the lower end getting standardized. Below that, solutionizing becomes a little harder. Productization becomes a little harder because you're reaching 48 volt range, and that's not a place where we typically like to play. So we would do systems that are more than 233, because these would be mid to high voltage systems.
Interesting. Just a related question to that before we jump into more commercial is, do you see a difference in prismatic cells or the cell configuration in terms making a difference in that scale, or is it not really a factor?
No, I think from a cell point of view, prismatic cells seem to be offering the lowest levelized cost and are now slowly becoming the norm. All the large top tier manufacturers now are moving towards prismatic cells, at least in stationary storage.
Mm-hmm.
The higher format cells, so today you have 280 or 314 AH cells, are today offering are sort of like the cutting edge in terms of stationary storage.
Mm-hmm.
The configurations that you are able to build with them uh, are the ranges that I was talking about. Your pack would
Mm-hmm.
like your racks would typically be 233, 279, 3 something. I'm forgetting the 343 if I'm not wrong, and so on. So those ratings then become the standardized blocks that can be created, and then you can have multiples of those blocks creating your microgrids. So depending on what range the project is talking about, you can either create a 20 feet standardized solution with a rack, with a AC skid, or you can create, if it's on the lower end of the spectrum, then you can have a rack and a separate inverter system with the EMS built in that can be shipped out easily. So those would be
Mm-hmm.
the two configurations that you could create.
Got it. Okay, great. Interesting. So moving back to more on the commercial side, we have some very kind of pointed questions about pricing per kilowatt hour and interest rates. So I'll address the interest rate question first. And that is Odyssey's interest rate varies by region, based on, local considerations, capital available, our own local structure for repayments. Generally speaking, we're around 1.2% to 2% per month. It can be subject to many factors: dollar availability, the nature of the project, the level of risks that we're considering, the level of deposit and commitment. There's many factors to consider, but what we do promise is that it can be more customized and faster than any other alternatives. So that's kind of on a case by case basis, but that's the range we work with. And then, if I may, kind of overstep a little bit to Ayush in terms of the ampere hour kilowatt hour question, and that's always the question, right? And then we all recognize that sometimes it's not as simple as such a straightforward answer. But what I can say in support of ampere hour and their own pricing is that when we do work together, we also recognize that supply chain costs can be a huge consideration, particularly in markets that have kind of more, let's say, frustrating duties and terms related to storage and the adoption of the storage technology. Happy to say that Odyssey is versed in those kind of those supply chain cost considerations. We recognize that the kind of FOB to DDP or CIF to DDP portion of any project related to storage. Sorry if I'm cutting briefly. But we recognize that can be a huge factor in consideration of your supply chain related to these costs. So what we can say is, in partnership with AmpereHour, we make sure we leverage the best landed cost available to ensure cost competitive projects and making sure that everything is imported compliantly yet cost competitive in the process. That of course looks very different by region. So over to you, Ayush, and then we'll come back with more commercial questions.
Yeah, I think on the commercial question is always the most important one at the end of the day for buyers, and we understand that there's an entire range of commercials available in the market. This is slowly becoming a fairly competitive space as well. Um, from our point of view, I think the way that we look at this is, as I said earlier, It's our intent is not to be the lowest cost provider. Our intent is to build risk adjusted, the best levelized cost system for a particular project. At the end of the day, capex is just one input. You have many other inputs to do the project financing, whether that's on the opex side or the life of the batteries, how they degrade, how safe the asset is. There's many other considerations that do play a role in deciding the cost of the system. And where we come in and we try to help the developer is to fundamentally quantify if there is let's say a 2% premium on uh, the lowest cost provider, what that 2% could actually be for. Or fundamentally like try to help the developer in terms of justifying why there is a price premium. What do they miss when somebody says that I'm willing to give you a 2% discount? So understanding cost and risk is extremely important over there, and we try to help you out with that.
Makes sense. Thanks for that context and reminder. Kind of moving on, maybe this is a good transition to some more technical questions. But we have a question here. You mentioned that you work with all the top OEMs to source cells and packs. Is the battery pack warranty provided by AmpereHour or the cell manufacturer? If both, how do they interact? Is the battery pack warranty transferable?
So for systems that are anything less than 50 megawatt hour, the warranties are directly provided by Ampere Hour. We would be backing it if there's a problem. Then all our systems come with a product defect warranty. We will make sure that we either repair the system, replace the system. This is all contractually agreed with the developer. For projects which are more than 50 megawatt hour, there it's a little more nuanced and a little more flexible. If there is a project which is sort of in the utility scale segment, then happy to connect with the developer and try to work out a mechanism wherein they feel more comfortable with the OEM also backing the work.
Makes sense. Yeah, I mean, a related question on the cells then is please suggest your solutions for 2C, 4C related BESS for industries. And it's interesting that we're seeing such C ratings now as common in questions.
Yeah, I think one thing is becoming clearer and clearer. Like essentially, if you for applications like power backup or applications where you need just a couple of minutes um, of charging and discharging, 2C and 4C would obviously give you the best project commercials. Now, from a 2C, 4C perspective, there's very limited number of battery suppliers who actually have the certifications for products to be deployed in markets. If if the gentleman who's asked the question can basically let us know where what jurisdiction or certifications are required on the cells, then we can come back to them with the appropriate solution. Right now, not all the cell manufacturers have certifications for every geography. So while they some geographies do not require a lot of certifications, you can apply those solutions there. In some others, if that certification is required, then it will take a little longer.
Makes sense. Yeah, interesting. Yeah, I mean, related, you're really getting into the UPS space, right? And as a backup there.
That's correct.
Interesting.
That's correct.
Are you seeing a change in the landscape in kind of traditional BESS companies kind of marrying more with UPS companies or related solutions, or the vice versa?
I think I'm seeing a bit of both, right? So you have the conventional UPS companies also trying to extend the duration of storage. So where they would be looking at only 15 minutes earlier, they're now looking at larger time frames. Um, as a native BESS company, our solutions are either designed for creating off-grid microgrids or creating grids, or to tie up with the grid to do various types of applications. Um, we are ourselves evaluating and building a 0 millisecond transfer time product, which would actually allow us to also provide uninterrupted power solutions to industries with a
Mm-hmm.
2C, 4C type battery. But at this particular point in time, we are still in the pilot territory. It's not commercially sort of scaled up yet. And this is something that we are going to be launching, like, I think 6 months out before we do that.
Well, interesting. Would you see the chemistry of such a battery the same LFP, or are you exploring alternatives?
Um, we're evaluating both LFP and NMC here.
Interesting. Great. Well, thanks for sharing that. We won't push it further. Yeah, a related question. Well, not. It's, I guess just a question on the protection and the safety on the fire system, both from a preventative as well as
Yeah.
explosive prevention system. What can you share?
So I think from a safety perspective, we've all heard of safety incidents with lithium-ion batteries all across the globe, and I think it's a very relevant question. Um, Now, in terms of our own systems that we design, we have multiple layers of fire protection that is inbuilt. So a few that I can talk about. Um, so at the container level, we have something that we call a preventive fire protection system, wherein we've ourselves built out an IoT board with some sensors that detect gases even before there is fire. So in the case of a lithium ion system, you do have certain gases that are released prior to the onset of fire. And that allows us to shut off the plant before the fire incident can happen. So that's one of the layers that we have developed in house, and that is part of the IP of the systems that we are also building out. Of course, it is additional cost, and this may jack up the prices by like 1% or thereabouts. But at the end of the day, you'd rather not have fire. The second is if there is fire, like we have Novak gas or some other firefighting system that is inbuilt within the container to be able to sort of diffuse the fire that might be there. For utility scale plants, we have an entire infrastructure for managing fire that is also built out. This would include water tanks and uh, a piping system that is actually inside the plant itself to be able to handle fire. So safety is by far the biggest problem that a designer looks into when designing the plant, and we try to sort of go overboard in terms of safety sometimes, but I think it's for the best.
Yeah, interesting. It's I could definitely say that seeing where the industry's come over the last 4 to 5 years, it's light years away. I always like to say that you can shoot these batteries with, a firearm and nothing would happen in terms of fire safety. So I think to kind of see the level of safety mechanisms and the incidents just dwindling is very impressive. I think we've stirred some interest here. We have a few more questions related to the C rating and the thermal management of batteries. You mentioned 4C rating in the market. It needs more critical thermal
Yeah.
management solutions. Can you please elaborate if it is possible in your system to use if can you please elaborate if it is possible in your system to use these cells and what are the challenges, if any? And I believe we have a related question in some ways you could tackle if it's part of the solution, and that is what other chemistries is AmpereHour considering, and including, well, I kind of made up that question, but including the use of sodium-based BESS, which of course is getting a lot of at least attention. But let's see, we'll hear from you. Is it getting the traction?
So I'll divide this into like two parts. I think the first would be on the C rate question on the thermal management. So um, uh, so as you correctly as the the person asking the question correctly pointed out, like essentially the higher the C rate, the higher the thermal management that is actually required of cooling these batteries, either when they're charging or when they're discharging. And that is an important problem to solve, to be able to build out safe systems at such high C rates. Now, from our own product development or solution development uh, uh, process, we are right now, there are cells available, that is true, but they need to undergo a very rigorous product development map, wherein you kind of first begin with building a pack. You evaluate the entire characteristics of that particular pack. You design the thermal management systems, whether that's air cooled, liquid cooled, or some other mechanism for cooling these batteries. Then you go through a certification process, which certifies the product as per IC or UL norms to be safe to be applied for a certain application, whether that's industrial backup or so on. We are currently in the phase of uh, sort of like getting our first in-house pilot to the certification process. So I can't talk a lot about the thermal management because, of course, that is kind of like crux of a lot of the IP that we're trying to build as well. But in a few months, we should have the certifications necessary to be able to commercially deploy these solutions in the market. I'd anyways like love to understand the project slightly better, understand like what cells you're talking about, and see if there is a collaboration that might be possible outside of this particular call. On the second question, which was around, I think, sodium ion. So sodium ion is has promising characteristics in terms of being abundantly available, lower cost of raw material, and so on. But if you were to ask me like today, right, as on date, I think LFP is still sort of the preferred technology because of the level of maturity of that particular technology and the scale up that it's already gone through. The good thing is, I think the standardization of the sodium ion cell and the lithium ion cells are happening in prismatic form. So for an integrator or for a developer, I don't think anything changes if we move from sodium ion to a lithium ion. You still get like a 20 feet container. In a lithium ion today, you might get like, let's say, a 5 megawatt hour. In a sodium ion today, you might get a 2.5 megawatt hour. But these densities will keep improving as technology goes on and so on. Also, sodium ion is early in its commercialization cycle. So today it might be more expensive than lithium ion. Maybe in a year's time that would have changed, assuming the scaling and everything is happening. So if you were to do like a R&D pilot, I would recommend going with a sodium ion. If you're doing a commercial pilot today, I'd say stick to a LFP system.
Makes sense. And it's great to hear that from an industry leader like yourselves, because it's so common to hear questions about sodium ion. But if you really look around and if you look at applications, you're just not seeing it. And that makes sense as to why, per your answer. So maybe we can end with just some comments about kind of our commercial adoption, specifically maybe in India and of course Africa, in which we're actively in partnership. But yeah, we have a question here about India specifically, and I know the Odyssey team and ecosystem is keen to hear your answer here because, as I mentioned, excitingly for us, we've had great success in India over the last year and a half, and we are really rapidly ramping up our support for the market there. And it's exciting because it comes with an entire ecosystem of new suppliers and new OEMs, as you're aware. And we really have two work streams there in support of that expansion. One is domestically, procuring from domestic suppliers and best leaders and others like yourself, but also in a kind of a south-south supporting of Ampere Hour and other Indian companies into particularly African markets where Odyssey has traditionally had a stronghold. So let's come back to Africa in my last question, perhaps. But the question is, with India's improving grid, is there still a strong business case for BESS and the C&I sector? And if yes, what applications?
So just to put some numbers into perspective, specifically for India, um, um, we are today on the Indian grid at less than 500 megawatt hour of energy storage. The Indian grid by itself is last number that I had checked was about, I think, 450 odd gigawatts, if I remember correctly. So you are at today less than half a gigawatt hour of energy storage systems that have been deployed on the grid based on uh, the rate, based on the targets of renewable penetration and decarbonization of the Indian grid. By 2031, 2032, we are looking at about 230 plus gigawatt hours of battery energy storage projects. So you have this massive journey that we have to go through on the grid. Now,
So,
in terms
Ayush,
of
was
the
that by 2031? Is that what you referenced?
Yeah, so this is a report. It's available online. Essentially, it's by the
Mm-hmm.
Central Electricity Agency of India that does the simulation study for planning. How
Mm-hmm.
much amount of renewables, how much amount of thermal, nuclear, and so on. And based on their estimates of cost curves and so on, they're basically saying 230 plus gigawatt hours of storage, right? So you
Wow.
have this massive journey that is still ahead of us in terms of deployment on the grid. Now, of course, this 230 will come up at different points in the power chain. Some of this will come ahead of meter, so this would come up at the generation and transmission and distribution side, and so on. So you will have this capacity coming up at different points. You will also have a lot of this capacity coming behind the meter, which is at the commercial and industrial premises. So, for example, in India, we do have commercial and industrial early adopters of energy storage, people like Coca-Cola, Amazon, Siemens, Sula Wines. So these are all
Mm-hmm.
customers who wanted to decarbonize with solar and so on. And I only see that trend, sort of like getting bigger. So the opportunity remains big, both ahead of meter as well as behind the meter on the CNI side in India.
Amazing. I feel like we need an entire separate webinar on this topic because it just raises more exciting questions such as virtual power plants and wheeling and how that is all going to work. And of course, data centers. Um, let's not forget the suction that is data centers. Uh, so let's keep that for next time. I recognize we're at the hour, and then just briefly to comment, excitingly, as I mentioned, we are in partnership in support of your Africa portfolio and expansion. And so particularly if there's anyone interested to discuss that and and what Odyssey and Ampere Hour could offer you in that regard, marrying our solutions, we'd love to discuss in support of the DARES program in Nigeria, in support of really now any markets. Odyssey is open for business with Ampere Hour across the continent. So, all right. Okay, I think we have, I'm seeing one more comment come in um, Okay, well, final question, so we make sure we address everyone here, and then we'll end. And please continue your questions offline if you'd like to have a discussion. We'd love to get into it. This question is for Justin. Can you help a buyer in importing BESS solutions from a Chinese manufacturer in India and customs clearance of the same? Absolutely. Thank you for the question. We have just built out our supply chain capabilities deeper across India. We recognize some of the nuances of the supply chain specifically to the Indian market. Of course, the first question would be, why not go with AmpereHour in that project? So we'd like to address that first in the process, but of course, we could look at supporting you elsewhere as well. That said, thank you so much. Thank you everyone for your time, Ayush. Thank you for your time. Thank you everyone for making the time on a holiday in India for those who join us from India, and then others elsewhere in the world. Stay tuned for our next webinar, and don't hesitate to get in touch if something today piqued your interest and you'd like to learn more.
Thanks a lot, Justin, for organizing this, and I look forward to interacting with you, in the near future. If anybody wants to reach out, please do write to us, and we'd be very happy to support.
Sounds good. Have a good day further. Thanks, Ayush.